In this short video, we are going to talk about randomization and bias. Before we do so, let's look at some quick review. Remember, gathering information about an entire population often costs too much or is virtually impossible. Instead, we use a sample of the population. The sample must contain the characteristics of the population in order to accurately represent the population. For example, if 90% of the students in this class were girls, it would not be an accurate representation because that's not what the entire Gutman student body looks like. Let's look at randomization, and you can get a better picture by looking at this image shown on the slide. Like I mentioned before, a sample should have the same characteristics as the population it is representing. In order to do this, a sample must be randomly selected. Each member of the population should have an equal chance of being selected. And we see an example of random selection in this image. Suppose Lisa wants to form a 4-person study group, meaning herself and 3 other people from her class, which let's assume has 31 members, not including Lisa. She could put all 31 names in a hat, shake the hat, close her eyes, and pick out 3 names. That's one way of randomly selecting a sample. A more technological way is for Lisa to list the last names of her classmates together with a 2-digit number, as shown in the table to the right. Then, once she has this list, she can use a computer to generate 3 random numbers between 0 and 30. This is actually a more common way in the real world. Usually when we want to generate a random sample, we use technology to help us do that. Now let's look at bias. Bias is the tendency to favor certain members of a population. In statistics, a sampling bias occurs when the sample does not adequately represent the population because of poor design or execution. Due to sampling bias, some members of the population may not be as likely to be chosen as others. This could lead to incorrect conclusions drawn about the population that is being studied. The following examples can lead to bias. One example is self-selection, and this happens when there are responses only by people who choose to respond, such as conducting an online poll on a website. Typically, people who choose to go out of their way to visit the website and complete the poll are people with strong opinions. So these people will be overrepresented in the data. Another example that can lead to bias is sample size issues. Samples that are too small are often unreliable. Bias can also come about from collecting data or asking questions in a way that influences the response. For example, if you don't account for confidentiality, let's say you're conducting a survey in which you're approaching people about their sexual history. Not everyone is comfortable talking about this, so you might receive responses that are not 100% honest. To avoid that from happening, you should create an opportunity where people can respond anonymously. Wording is also important. Let's say you're conducting a survey in which you ask people, for healthier dental hygiene, you should be brushing your teeth twice a day. Do you brush your teeth twice a day? Because of the wording, a person who would have originally answered no to this question might be insecure about saying no because of that assumption that you threw in, even if that assumption is true. So then the person might dishonestly say yes. To improve the wording of this question, we should eliminate the first part and simply ask, do you brush your teeth twice a day? Let's look at a few more examples that include bias and talk about why they are biased. Let's say you're conducting in-person interviews to ask people if they have done drugs. Again, this is a confidentiality issue. People may answer dishonestly or not at all. For that type of survey, you have to create an opportunity for people to answer anonymously. Let's say you're throwing darts at a map to decide which states you should sample. If you're using this technique, you might think you're being random, but you're actually not. This is not random because you're technically aiming at where you're throwing. So there's some type of selection happening. When you're selecting what aspects to survey in a sample, you have to be as random as possible. Then for the third example, let's say you want to conduct an online survey posted on a news website. We talked about this before. The issue, again, is self-selection. Only people who feel strongly motivated enough to go out of their way and visit the website, complete the survey, will do so. So you are likely to get an overrepresentation of strong opinions. Let's briefly talk about how all of this connects to experiments. So there's actually specific vocabulary we use when discussing randomization in experiments. Let's think about control groups again. Remember, knowing if you're in a control group defeats the purpose of a control group because the control group doesn't receive the treatment. Blinding refers to subjects not knowing which treatment they are receiving. This is often accomplished by giving the control group a placebo, because remember, the placebo looks like the treatment, but actually does not have the treatment in it. Double blinding refers to subjects and those evaluating their responses, not knowing who received which treatment. Remember, we talked about lurking variables, and lurking variables are variables we didn't control or plan for that can affect the response. So to account for lurking variables, the researcher must accomplish random assignment. When subjects are assigned treatments randomly, all of the potential lurking variables are spread equally among the groups. In conclusion, a sample will never be an exact representation of the population. This is impossible. We want a sample to be as close as possible to the population, but obviously it never will be. However, a general rule is in order to avoid error and bias. The larger the sample, the better. Samples that are too small may be unreliable. And of course, the sampling method must be as random as possible.